then you can ask questions whenever you want. And please respond to the questions that I'm going to ask as well, because I'm going to give you challenges along the way. The point of these 2 weeks, called the Big Catch Up, is we're trying to help people who've missed out on school and missed out on lessons, because in the UK, 2/3 of all students have had no online teaching since March. And it's, I don't even know the figures for the rest of the world, but could be even worse. So we're running these catch-up sessions, and today is high school maths, which is gonna kind of be aimed at ages like 13 to 17. We're gonna do straight line graphs. So it's gonna be like, well, I'll tell you what we're gonna do. First, we're going to talk about this frog and what it has to do with custard. And then when we've done that, then we're going to talk about gradients. And then we're going to talk about line equations. And then we're going to talk about, what are we going to talk about after that? Parallel and perpendicular lines. And then we're going to work through some kind of problem type things. And Olive says, yeah, I love graphs. Wow, that's a rare thing, but that's great. I'm glad you love graphs. I actually really like graphs as well. I find that, I mean, I'm a bit dyslexic, so I'm quite slow at reading words and long passages. So I love graphs and pictures because I can absorb information from them really quickly. I don't know if you guys find the same thing. Quick aside, I was reading the other day that like a lot of people regard kind of like dyslexia and ADHD and these kinds of things as like illnesses and diseases. That's so absurd. These things are just like part of the spectrum of the way that different people's minds are, and the fact that we put labels on them, I guess, just helps people to figure out where their strengths and weaknesses are so they can focus on the right things. I know that I'm really, really slow at reading. I love reading, especially about like ancient history and stuff, because I don't know why, I just really like that. But I also know that I'm really slow at it, which is why I love graphs, and that's why it's particularly important for us to learn about straight line graphs today. Although, let's start by learning about this frog. So here's a frog, and I've selected this particular frog because of its big tongue sticking out here. Oh, there we go. Did not circle the tongue very well. Okay, so does anyone know what is special about a frog's tongue, or actually not just its tongue, but the saliva all over its tongue? Saliva. What is special about a frog's saliva and custard? So what does frog saliva have to do with custard? Does anyone have any idea what's going on here? What the thing is that they have in common? So Miz is saying good frogs, and also that it's sticky. Jack is saying that's cute, but it's so horrible. Miz is saying are both delicious. I don't know if a frog tongue is delicious. Although, you know, if you do kiss a frog, then it is quite possible that they turn into a person according to what we are taught from fairy tales. Isn't it amazing that we're taught so many things that are just not true? It kind of goes to show that there must be loads and loads of things that all adults believe in, that having grown up and being taught stuff that just isn't true, because we're so good at believing things that aren't true. All I was saying, is that what custard's made of? And that's gross. No. Okay, right. So I'll tell you what it is. Right, so if you have a swimming pool and you fill the swimming pool up with custard, then do you know what you can do with that swimming pool that's quite unusual? So in this kind of red stuff I've got down here, let's call that the custard. We'll put it yellow underneath. Maybe it'll get a little hard layer on the top, or harder layer. So what can you do with a swimming pool full of custard? Does anyone know? You might have seen this. So Oliver's saying non-Newtonian, and that's brilliant. Yes, so walk on it, maybe not, but run on it, yes. And the reason why you can run on it is because normally a material, if you push really hard, you'll go through the material, right? If you like push really hard into water, you'll go through water. And if you're more gentle with water, then you won't go through it as much. So a non-Newtonian material is one where a non-Newtonian material is one where if you hit it really hard, it becomes really hard. And if you touch it really softly, it becomes really soft. And so if you take your swimming pool full of custard and you run across it, then as long as you're stepping really hard on top of the custard, you will not sink into it. So this is not the same as frog saliva. Frog saliva has got a special trick, and it's actually really cool what frog saliva can do. So think about, what does frog saliva have to do? What's its main game for a lot of frogs? What do they need to make their saliva do? And yes, there will also be a large dessert available for those who make the swimming pool full of custard. Yes, exactly, catch flies. So they've got to be able to catch flies with their tongues. And so rather than their saliva going hard when it impacts the fly, frog saliva does something different. So frog saliva, as soon as it touches the fly at high speed, goes really soft. And that softness allows the saliva to kind of surround the fly. And then as soon as there's a kind of lack of tension because the impact's over, that's when the frog saliva suddenly solidifies. And then it can pull its tongue backwards and the fly is trapped in the saliva. So frog saliva is this amazing fluid that is absolutely perfect for trapping flies, which is really rude for all the flies because, it's just, well, the flies probably aren't up for it. Anyway, so yeah, mystery solved. That's what custard and frog saliva have to do with one another, is that they kind of they have similarly weird properties when they experience a high impact. I'm wondering if it's about to get noisy outside, so actually I'm just going to close this window. Right, okay, so so Miz is saying yes, so opposites custard, and that's exactly right. So the frog saliva is quite opposites custard in the way that it behaves relative to impact. Okay, so let's go down here and start explaining some stuff about lines. So first of all, and this is something that if you watched one of my physics ones last week, you will have already seen me talk quite a lot about this. So gradients. Like understanding what a gradient is one of the most important elements of a straight line. So first off, who knows what a gradient is? Let's see what ideas people already have. What is a gradient? And while you're throwing in your answers, I'm just going to quickly draw us a little graph. So remember, whenever you draw a graph, you need an X label and a Y label. I'm going to draw us this orange line and also this blue line. So Miz is saying slope, Karina is saying the steepness of a line, and this is really great. Yes, so the gradient is the steepness. It means how steep the line is. So which is the steeper line? Just to make sure everyone's okay with the idea of steepness, which is steeper, line number 1 or line number 2? And Oliver's saying as well the steepness of the slope, and P is also saying the slope. Brilliant, and Jack's saying number 2. Yes, so number 2 has got the biggest gradient. Right, now in straight lines, this is one of the first most important concepts to understand, that the gradient is the steepness of the line. But you also need to be able to calculate how big the gradient is. So let's just look at this blue line, and let's say it's crossing the axis here at 3. And let's say then we measure this point here, and we find that this is 5, and this point here is 12. So can anyone tell me what the gradient is of the blue line? Now, for those of you who don't know how to do this yet, that's absolutely fine. I'm now going to show you, but I'm interested to know who already knows. So the way to calculate the gradient is to take the rise over the run. So these words might seem weird for now, so let me explain what I mean by them. So if you start at this point here, so this is one of the points that we know, then you are running across by this amount. So how far do you run across? If you're going from 3 to 5, then you're running across by 2. And then when you get to here, you rise up by, so you're going from 0 all the way up to 12. So you're rising up by 12. So if you rise by 12 and you run along by 2, then the rise over the run is going to be 12 over 2, which, like some have said, is 6. Yeah, exactly. Good. So the rise divided by the run is going to be 6. Cool. Okay, so let's just see, just to make sure everyone's kind of following this. Now let's look at the orange line. So on the orange line, let's say that here is 4. And let's say we're going to measure up to, how far should we go? Let's go up to here. So let's say this point here is 10. And let's label this point here as 6. So what is the gradient of this line number 1? So have a go at working it out yourself, but again, I'm going to work through it. So again, the gradient is equal to the rise divided by the run. So let's start here, and we're going to end here. So to get from there to there, we are going to need to run across by how many? See if you can see how many that is, and then we're going to need to rise up by how many. So we're running across from the beginning all the way across to 6. So we're running across by 6, and then we're rising up from 4 up to 10. So you're rising up by 6 as well. Great, so it looks like everyone's starting to follow this, which is perfect. Good. So yeah, the rise over the run is going to be 6 divided by 6, which equals 1 for this one. Really, really good. Cool. Okay, now let's do this again. Just to make extra specially sure. So let's do, oops. Let's get another graph. So now I want you to find the gradient of these two lines. So I'm going to give you this red line here and this green line here. So often with lines, you'll only be given the intercept. So that's the point that it goes through the axes. So these things that I'm labeling X and Y, those are the axes. So this point here is an intercept because it goes through the Y-axis here. So let's say this one is going to be, let's call this -5. And then over here it's going to be 10. So what's the gradient of the red line going to be? So that's going to be gradient number 1. Now, also, I want you to have a go with the green line. So let's say the green line is going to be up at 12. And then let's say it's going to drop down here to 6. So that's number 2. So have a go at doing those. I'm going to write them down as well. So the gradient, like we said before, is the rise over the run. Now, you might also see it written down in a slightly different way. So you might also see it written down as delta, which is a Greek symbol. It's just like a triangle, y, and over delta x. So this means exactly the same thing. If you're working stuff out and you haven't seen this before, you might just want to stop for a moment and let me show you what I mean by this. So this is just like the posh mathsy way of saying rise, because it just means the change in y. So if we're looking at, let's look at this bit here. I know this is not the bit that we're measuring in our question, but if we're going from here to here, then we already know that this is the rise and this is the run. But notice how the rise is just the change in y. It's how much our y changes. So how much do we go up in the y direction? So another way of writing it is change in y. And the run will sometimes write as change in x. So how much does x change? So I'm going to write sometimes rise over run, and sometimes I'll write change in y over change in x. It means exactly the same thing. Okay, so for the red one, line number 1, we are starting at here, and we're going to run across by 10, because we're going from 0 up to 10. So we run across by 10, and then we rise up from -5, like that, which means we're rising up by 5. So the change in y, or the rise, is 5, and the change in x, or the run, is 10. So it's going to be 5 over 10, which is going to be 0.5. Now, I've seen that some people have written minus 0.5 there, and don't be fooled by the fact that there's a negative number. So you will always know if the gradient or the steepness is going to be positive or negative, because you can imagine being at the beginning of the slope, like literally being stood there and walking up the hill. If you're going up the hill, up is positive. So going up the hill will give you a positive gradient. Here is where you might get is where you're going to get a negative gradient, because you're going down the hill. So we'll talk about that in a mo. But here we're going up the hill, so we're going to get a positive gradient. And so we always read from left to right and show that we're going across by 10 and then up by 5. So this is just 5 over 10, which is 0.5, not negative 0.5. Okay, so the green one, I've seen that P's put -2, which sounds good. And Karina has put -2 as well, which sounds good as well. So let's go through this quickly. So for the green one, we are going to start here and we're going to finish here. So first, let's see how much we're going to run along. So we're going to run along by 6, because we're going from 0 across to 6. And now this is where the word rise comes in extra specially handy, because rise makes it very, very clear that you're supposed to be rising. So if you run along and then rise downwards, then you've got a rise that is negative. So our change in y is now negative. We're going down by 12. So across by 6 and then down by 12. Because we're reading from left to right, you'll always find that your change in x or your run along is positive. It'll just be your rise that is positive or negative. So we're running along by 6 and we're going down by 12, which means that the gradient is going to be, so the change in y divided by the change in x is going to give us -12 over 6. Oh, I saw that there was a little bit of buffering going on. Yeah, basically, I've just I had this internet contract that literally ran out today, so I've just had to switch to a much crappier internet. And so every now and then it might buffer, but it should be all right. Seems to be running okay. But anyway, I'll maybe just really, really quickly explain the green line again. Nexus King Singh says buffering for 5 minutes. So it's not buffering that bad here. I just saw like a tiny bit of buffering for about a minute. Anyway, right, let's go over the green one again. We'll see how far I can go back. Can't go back that far. Okay, right. Let me just delete these bits and I'll just explain the green line one more time. Okay, so for the green line, we are trying to get from this point to this point. So again, we are going to run along from here to here. So again, we're running along, and so we're going from 0 across to 6. So therefore, we're running along by 6. And now this is the point where the word rise becomes really, really important, because you can very clearly see that from here to here, you are not rising, you're going downwards. And so therefore the rise is negative. You're going downwards by 12. So so the change in y here is going to be -12, and the change in x is going to be 6. So when you go to calculate your gradient, you're going to do the change in y divided by the change in x. And so now we're going down by 12 and across by 6, which means the gradient is going to be -2. Perfect. Really good. Okay, great. Now let's. So that's how gradients work. Does anyone want to do a practice of one more gradients, or should we move across to the next thing? Up to you guys. Quick time for a vote. And while everyone's voting, let's just go up to this frog with its saliva that's like the opposite of custard again, and consider that frogs are really great. And frogs are one of the first things that that disappears in an ecosystem that's starting to collapse. And so when you go to a place that is full of frogs all jumping around in the forest or wherever, that's how you know that the ecosystem is really, really healthy. And when I went to visit Ireland with my brother, and we were walking through this ancient forest, and it was full of frogs. There were so many frogs, and it kind of reminded me that I was sure that there used to be more frogs as well when I was younger. Okay, so we want to do one more gradient. Let's just do one more quick practice of gradients. So we're going to spend a lot less time on it this time, but I just want to make sure everyone gets it. So here we go. Let's have another graph. Okay, so let's have this line here, and let's have this pink line here, and we'll do another one that's like that actually. Okay, so this can be line number 2, and this can be line number 1. So let's say that both of these lines meet at let's call this 16, and this here can be 9. Right, now let's make this down here -7, and then up here we will have 13. So what are the gradients going to be of lines 1 and 2? So again, like, race me if you want to try to put the answers in. I'm going to quickly go through and explain how they work. So for line number 1, let's start here. So we're going to run across and we're going to rise up. So if we look at the run across, we're going across from 0 across to 16. So this run across is going to be 16. And the rise up, we're going from -7 up to 9. So what do you think that's going to be? -7 up to 9 is going to be up by 16 as well. So yes, Karina, that is brilliant. So yeah, we're going up by 16 and we're going across by 16, which means that gradient is going to be 16 divided by 16. So for number 1, the gradient is 1. Now for number 2, yeah, perfect, Olive. That's really good. Now for number 2, what do you guys think the gradient is going to be? I wonder if Exodus Kings is still on and can tell us what the gradient of the pink one is going to be. So here we go. Yeah, if we start here, then we're going to run across. Again, we're running across by 16. It's the same distance across. And then we're going down. So here we're going down. So the rise is going to be negative. So we're going across by 16. And then if we go down by 4, so that's -4, then what is the gradient going to be of the pink one? Now, while everyone's just throwing in their answers there, I just want to quickly say, since we're over halfway through, but we at Aim High have decided that we're really keen to like chat to some of our students and try and work out how we can do things better and what kind of things you like and what kind of things you find hard, and basically how we can make this better. And so over the next few weeks, we're not going to be doing as many lessons, but we're really keen to chat to like some learners, maybe even some like teachers, and basically we're going to chat to as many people as possible. And if you are up for talking to us or doing like, yeah, basically like chatting to us about your learning and stuff, then please email this email address, which Marianne will reply on, and she's really nice, and she will set up some kind of call where we'll chat to you, and yeah, we'd love to learn from you. So if you're up for it, then do please email that. No pressure if you don't want to, but yeah, it's team@aimhigh.co. So jot that down if you're game. And if some of you may have already emailed as well, because we've already been like compiling the few email addresses of people who are up for it. So yeah, Olive, if you already have, that's brilliant. Right. Okay, so onwards. Let's see if we got. So yes, pink is going to be minus 0.25. Perfect. Pink is going to be minus 0.25 because we're going across by 16 and down by 4. So minus 4 over 16 is going to be minus 0.25. Okay, right, next bit. So let's do line equations. Going to go across to here. Pop that there. Okay, so the next thing to know about straight line graphs is the line equation. Now, I find that often school teaches you lots of different kinds of equations for lines, and my line on this is that you literally just need one equation. You need one equation. This equation will serve you for all the straight lines that you ever do forever. It's such a good equation. So all you need to know is this, and it might seem weird if it's the first time you've seen it, but this is going to come in seriously handy, so you need to try and remember this. So the equation goes y equals mx plus c. And it works like this. So let's just draw out a quick graph again. So if this is our graph, again, let's label the x and let's label the y. Then if you have a line like this green one, then the gradient of the green line, so let's say the gradient is 3. Oops. So if the gradient here is 3, and it goes through the y-axis at, let's say, 2, then the equation for this whole line is y equals 3x plus 2. Now, this might seem weird to begin with, so if you haven't seen this before, so let me just explain what I mean. So this equation is an equation that works for all straight lines, and the letter m stands for the gradient. So if you have a straight line, then it's going to have a certain steepness to it. It's going to have a certain gradient. And because it's straight, it's just going to have the same steepness the whole way. And so we can work out what the gradient of our straight line is, and it becomes this letter m. So we start to use m to represent the gradient. I don't know why, it's a bit annoying actually, it should be g, but it's m. And then we use this letter c to represent the point at which it goes through the y-axis, and we call this the y-intercept. Cool. Okay, so this gradient is now true for every single point on the line. So for example, if we were to say, let's say x is 5. If we say x is going to be 5, then you can put that here. So 3 times 5 is 15, plus 2 is 17. So if x is 5, then that tells us that this point here is going to be 17. Now, similarly, you can put in another point. So can you guys tell me what we'll get if we sub in x equals 8? So if x equals 8, then what will the y coordinate be? What do you think? If x equals 8, what will the y coordinate be? So just put 8 into here. If you put 8 here, then what will the y coordinate be? So 3 times 8 is going to be 24, and then plus 2 is going to be 26. So Karina's got it, and Piggy's got it as well. Perfect. Yes. So let's label this point as 26. And as you can see, this graph is starting to look not very well to scale. But anyway, okay, that's great. So now let's have a go at me giving you guys a graph, and let's see if you can work out what the equation for the graph is. So here we go. So here's our graph, X and Y. And now let's send a green line through here. So if I tell you that this goes through at 3, and there's another point over here, which is, let's say this is going to be 6. And this is going to be 6 as well. Then what is going to be the equation of this line? So have a go at working this out yourself. But if you're feeling stuck, I'm going to start going through it now. And if you just want to work it out by yourself, you can ignore me talking while you work it out. So if we start at this point here and we go to this point here, then just like we were doing before, we're going to run across and then rise up. So how much do we run across by? We're going from 0 across to 6. So we're running across by 6, and we're rising up from 3 to 6. So we're rising up by 3. So the gradient, m, let's start calling it m, is going to be 3, how much we're rising up, the change in y, divided by 6. The gradient is going to be 3 divided by 6, which is going to be a half, or 0.5. Now from there, you can just write out the equation, because y equals m is the gradient, x, plus c. So we just need to fill in this gap and this gap. So what's the gradient? We just worked it out. The gradient is a half. And what's the y-intercept? Where does the line go through the y-axis? It goes through at right here, at 3. So y equals a half x plus 3, which I can see that Olive has written, which is great. Karina's written that as well. Jack, I think maybe you meant to write that, but I can see you've missed out the x. But yeah, that is really, really great. Well done, everyone. Cool. Now let's try giving you one that is a bit harder. Now this is quite a bit harder actually, but it's good. It's good practice. So let's. In fact, maybe we'll just go straight in. Okay. Let's just go straight in at the kind of slightly deep end and see how you go. So if I just give you 2 points on a line, so if I just say to you, there is a line, and one of the points on the line is 3, 4, and another point on the line is 5, 8. So this is the kind of question you might often get. They just give you 2 points and they say, right, what's the equation of that line? And then you have to work it out. Now, you can start in several different ways here, and it kind of depends on how you want to do it. Personally, I usually start by kind of sketching something out that will help me to kind of visualize what's going on, because otherwise it gets a bit confusing. So I'm just going to do a quick sketch. Here's our x and here's our y. So 3, 4, so I'm just going to put that kind of here. Three and 4. And 5, 8, let's just pop that over here somewhere. So the first thing I would do is try and work out the gradient. So who can tell me what the gradient of this line is going to be? Let's try and work out what the gradient is. So I'm going to start to do this with you. So what is the change in x and what is the change in y? So the change in x, we're going from 3 to 5, so that's 2. And the change in y, we're going from 4 to 8, so that's 4. Perfect. So m equals 2. Karina, that's really great. I think you've got the full thing. So yeah, the gradient is 2 because it's going to be change in y divided by change in x. So our gradient is 2. Now that we've got the gradient, we can now look at our line equation and be like, okay, well, we know the gradient, so we know that it's going to be y equals 2x plus something. And now the only challenge is, how do we find this y-intercept? How do we find the point that it's going through the y-axis? Now, we could just kind of like look at our sketch and draw a line and kind of think, oh, well, it's kind of going through down there. But ultimately, our sketch wasn't very accurate because it was just a sketch. I just randomly placed these numbers in. I didn't kind of carefully measure where they're supposed to be. And so we know it should be vaguely down here, but we don't know what the y-intercept is. So we have to work it out. And so to work it out, the easiest way is just to take one of the points, like this point, and just put it into the equation, because this equation has to work for all the points on the line. That's the point of the equation. The equation is one that is true for every single point along the line. So try subbing this in. Now what I mean by that is that 3, 4, so x is 3 and y is 4. So try subbing that in, and can you guys tell me what c is going to be equal to? So if x is 3 and y is 4, then what will c be? So I'm going to start subbing these in myself. So 4 equals 2 times 3 is 6 plus c. Perfect. So Piggy's got this as well. Yes, which means that c is going to be minus 2. C has to be minus 2. That's the only way this can make sense, which means our final equation is going to be y equals 2x minus 2, which I can see that Karina got as well before, which is brill. Nice. Okay, so y equals 2x minus 2. Now, if you want to check it, you can take this point as well and sub that in, just to make sure it works. So let's quickly do that. So if x is 5 and y is 8, does this work? So 8 equals 2 times 5, that's going to be 10. So 10 take away 2 is 8. 8 equals 8, so that works. Great. Okay, cool. Now, who wants to do, let's get a vote. Who wants to do another kind of simpler, like relatively simple one of those? Well, sorry, I say relatively simple, I mean like similar to the one we've just done. Or who wants to do one of those that's a bit harder still? So votes for something a bit harder, votes for the same thing as practice, or votes for moving on to the next thing. What do you guys want to do? Okay, so it looks like we generally want a repeat of that kind of one. Okay, cool, let's do that. That is fine. So let's just get rid of all this stuff here. Okay, so we want a similar one. Let's do this then. Okay, so let's say we've got another 2 points, and these points are now going to be, let's do -1 and 5. And let's have and let's go up to 2 and 20. So if these are our 2 points, then what is the line equation that links them together? Let's pop them up here so that we can draw below. So in our question, we've got these 2 points here. What is the line equation that links them together? So again, I'd encourage you to start with a little sketch because it always helps to make things a bit clearer. And again, the thing about sketching lines is that it just doesn't have to be accurate. As in, it doesn't have to be perfect. You don't need to measure things out. You don't need to use squared paper. You just put it vaguely where it looks sensible, and it will really help to visualize what's going on. So if we've got -1 and 5, then that means we're -1 and 5. So maybe here. -1 and 5. And then our other point we've got up at 2 and 20. So let's say that's going to be up here. So 20 and 2. So who can work out what the gradient of this is? What is the gradient of this line? So how far do we run across? And how far do we run up? So what is the rise and what is the run? So Olive and Piggy are both saying 5. Brilliant. Karina's saying 5 as well. This is great. Yes. Okay, cool. So we're rising up by 15. We're running along by 3. And so the gradient is going to be 15 divided by 3, which is going to be, which is going to be 5. Yeah, so our gradient is 5. Now, the next thing we can do is take our equation and be like, yes, we've made some progress. We can put a 5 in here for our gradient. So y equals 5x plus c. And I would always encourage you to find the gradient first. It's so much easier if you found that. And now we know that this equation is true for every single point on the line, right? This equation is true for all the points on the line. So you just need to take one of the points. So you could take this one or this one, it doesn't matter, and sub it into the equation. I'm actually going to take the second point while I'm working through it, but you guys can do whatever you want. So I'm going to use x is 2 and y is 20. So if y is 20 and x is 2, then that's going to be 5 times 2 is 10, plus c. So c is going to have to be 10. Y equals 5x. Ooh, I think Olive and P-Lover, I think maybe it's y equals 5x plus 10 rather than that second equal sign. Well, I was wondering if I was misreading it. So yeah, so we know that c is going to have to be 10. And so now we can upgrade our equation to show that the final answer is going to be that we've got a 10 here. So y equals 5x plus 10. Oh, well, thanks for coming, Piggy. You've been very welcome. And I'm sorry that your battery is about to die. Hope you get it charged sometime soon. Okay, cool. Right, now I kind of just want to show you one more thing, which will be useful. So here we go, it's over here. So this will only be quite quick because I think we should probably finish the lesson in a mo anyway, but I'm just quite keen to show you this last bit. So parallel and perpendicular lines. So if two lines are parallel to one another, what does that mean about their gradient? What does it mean about their gradient if these two lines are parallel to one another? Now, if you don't know what parallel means, parallel just means that you've got two lines that are both going in exactly the same direction. So if you were to follow both of them forever, they would never cross one another. They would just keep going at the same distance apart forever and ever and ever. We often label them with arrows like this to show that these two lines are parallel. And if you have other lines that are parallel in another place, then you might label them with 2 arrows to show that they're parallel to one another, but not parallel to these lines. So, if 2 lines are parallel, then what does that mean about their gradient? What does that mean about the gradients if they're parallel? Exactly, the gradients are the same because the steepnesses are the same. Nice, Karina, and Sedan got that as well. Great. Welcome, Sedan. Haven't seen that face before. Seen your face before here. So yes, they are both. They're both parallel. They both have the same gradient. So if we know that this one, let's extend this actually a little bit. So if we know that the equation for this line is y equals 4x plus 2, and you know that this line goes through this point here, so let's say it goes through minus 6, then who can tell me what the equation of this second line is going to be? I'm going to do this in green. So what is the equation of this second line going to be? So look at this first line, and this line has got y equals 4x plus 2. So it's got a gradient of 4 and a y-intercept of 2. So we know it's going through at 2. So what is the equation for this second line going to be? So yes, I can see Karina smashed this and got exactly the right answer. So y equals 4x, so exactly the same gradient because they're parallel, but this time minus 6 because it's going through at minus. Now, the last thing I want to tell you, and I just want to show you this really quickly because we should finish the lesson here, is that if you have two lines that are perpendicular, so what I mean by that is that you've got two lines that are So what I mean by that is that you've got two lines that are at right angles to one another. So let's say you've got this orange line and you've got this blue line. Then the relationship that links their gradients is like this. So if this one has a gradient of m, then the other one will have a gradient of minus 1 over m. So if the gradient of this orange line is 5, then what will the gradient of the blue line be? Exactly. So this is called the negative reciprocal. So reciprocal is like a kind of posh word in maths that's used to mean 1 over something. So 1 over the gradient is the reciprocal, and negative because there's a negative sign in front. So if the gradient here is 5, then the gradient here is going to be minus 1 over 5. Cool. And this also works in the other direction. So if you were to do minus 1 over and then put in brackets minus 1 over 5, then if you simplify this, then you will find that it just takes you back to 5. So basically the negative reciprocal, minus 1 over the gradient, will just flip you between these two gradients. It'll flip you between the two gradients that are perpendicular to one another, so they're at right angles to one another. Okay, so I'm not going to practice that, but I just wanted to show you that. In fact, I'll just write it here. The way it's all often written is gradient 1 is equal to minus 1 over gradient 2. So that may come in handy if it's something you didn't know already, and I wish I had a bit more time to practice it, but we should finish here, I think. So thanks so much for coming, everyone. If you haven't already, do follow our socials, and you can sign up to our schedule here and check out the schedule of what's coming up for the rest of the day. I'm going to be back in a couple of hours to teach more maths. In fact, it's my last maths lesson of the big catch-up, so do come along to that if you can. And also there are other lessons going on today, and there are other lessons going on tomorrow as well in biology and chemistry, so come along to those as well. And yeah, thanks so much for coming. Do tell your friends, and if you'd like to give us feedback, then you can always do so anonymously on the form below this live stream on our website. Or if you'd like to chat to us, which would be great because we're keen to chat to some of our students, then please email team@aimhigh.co, and we will reach out to you over the coming weeks to arrange a call or something. So yeah, thanks so much, everyone. I will see you guys later on. Farewell.